In fact, when we speak about the infrastructure for the drone technology, we want this to be as small as possible, and we want this lecture to be as short as possible. In some sense, this is the whole reason to be so excited about the drone technology, is that they don't need too much infrastructure. If we have to establish infrastructure, that would kind of be the purpose, or one of the purposes. So, if you look at other kinds of traffics, well, there are these means of transportation. You have to build roads or rails for railroad traffic. And then you have to have some control and traffic lights, these physical things and control centers, in particular in aviation. Of course, there are air traffic controllers, and the airports are serious and large investments with a lot of land use and so on and so forth. And the idea with the urban air mobility is that you would not have to have too much new infrastructure. So when we're thinking about air taxis, in particular the passenger transports, okay, well, we have to have vertiports. Probably they will not land everywhere. But again, the idea is to use the roofs, so maybe spots at gas stations, and maybe not too many specially built vertiports. And when we go to the drones, then the idea is that, well, they basically will start and land anywhere. So PK, I mentioned him, Dr. Parimal Kapardakar from NASA, who was the principal investigator on NASA's UTM project. He gives a lot of talks, and one of the talks in Google, in one of the talks, he had this citation that essentially you will have the drones start and land anywhere, more or less no infrastructure needed. And when we speak about traffic management, U-Space, UTM, yes, you do need to have it in place. But again, the idea is that you would have something that could be called software-defined airspace. These geofences, they will not be physical. They will be just there on the map. And everything will be highly automated. There will hopefully not be too many people like we have in case of the air traffic management, where there are controllers that are responsible for the aircraft. The more is done by the automation, the better it is. So all in all, for the small drone technology, at least, the idea is that hopefully there will not be a need to establish a large infrastructure. So the vertiports are probably the one and only part of the UAM, UTM, where you need to do infrastructural investment. And I will just briefly go into these slides. The first ones prepared by our colleague from DLR, Caroline. I will not try to pronounce her last name. This is a short set of slides, and she presented them at that workshop, a symposium, whatever you call it. This was virtual. Anyway, speaking about the verti-drone design, and you will see what it is. That there are many terminologies, as always, the key, and as always it is a mess. So yes, so you know what the vision for the urban air mobility, then what's the need for the urban air mobility infrastructure. Regulatory framework, we looked at it. When it comes to the drones, there is not much on the vertiports terminology as usual. And then there is some technical ideas of how they do an assessment of the vertiports, but we will not go into much details on them. Basically just flipping through the slides. Nice pictures looking at historical ideas of how the heliports or helidromes would look like versus the current view. Right, and then the infrastructure, in particular, this difference of the UAM infrastructure, both from the airport, when you need it for the conventional airplanes, and also from the heliports for the helicopter operations, where again there is a lower frequency, and yes, they're less affordable, so they're more or less expensive. Now, for the UAM ground infrastructure, as we've seen some of the challenges also ourselves, well, they should rather be, the services should be on demand and not too expensive, going with high frequency. We know that there is complex obstacles around. We looked at the airspace availability, and terrain and all these other obstacles, airport procedures. Yes, so there should be connection to the existing infrastructure and other modes of transportation. Yes, there should be as little human oversight as possible. And yeah, these steep or vertical takeoff and departures, they're well related to this complex obstacle scenery. Yes, you will have to fit yourself between buildings and maybe trees and maybe other things. So that makes the UAM vertipaths different from the say heliports, which are usually on top of the buildings. For airports, the terrain is yeah, that's quite an important obstacle. There are quite a few procedures where you have to go between the mountains, and that makes things more complicated. Yes, so some of the yes clarifications of for this UAM tailored infrastructure, that it should be on well, it should be on demand in terms of time, and should be fit well to the demand that you have on the ground. Yes, the obstacle scenery and other things we looked at that. Weather is a really important player. Again, I guess I will have another slide devoted to it. Yes, the urban weather, heat islands, yeah, urban canyons, hyperlocal winds, they will probably be hard to deal with, but they have to be dealt with one way or another. And we know that weather prediction is not ideal. And of course, in conventional air traffic management, we work a lot with weather prediction and how to use it. There is much less known on this smaller urban scale of, especially for these lighter aircraft or drones or even air taxis, how the weather will influence their routes. That's an important question. So yes, regulatory framework, yeah, there is probably not much yet on the vertiport design per se, but we looked at regulatory framework for U-Space in general. Yes, this slide. So it was Caroline with whom we worked in project, and she was bringing up all these different names for maybe similar things, maybe somewhat different things. Yeah, they tend to call it vertidrome. There's vertiport, but there's also vertibase and other things like greenfield mobility hub. As usual, terminology is hopefully settling in. So far, there is a lot, but more or less we understand what it is. Places for takeoff and landing for yes, UAM, urban air mobility. Right, and there are some challenges and difference between the regulatory framework. Here on the left, there is a citation from ICAO, and on the right is from a research paper. Yeah, we know that not having the well-defined terminology is a challenge. Right, and then there is a few slides of how they do an assessment of the operations, of course, in the lab, because it's expensive and not always possible to do it in reality. Yeah, so they define certain KPIs and see how well they can be followed in simulations. I'm not going to go into these technical details. Yeah, so in summary, well, there is some state of the art when it comes to the vertiports, and things are changing. There is a regulatory framework. We looked at it, and yes, the evaluation of the vertidrome's capacity and other KPIs is done in the labs, but there are also very large demonstrations, as I mentioned, particularly within the SCORUS XUAM project. That's the project in which we sit together with DLR in particular and LFV, and we will hopefully have the demo flight in Sweden next year. So let's see, maybe there will be something else to measure in reality and not just in the labs. Okay, so that was a set of slides from DLR. Now there is also another set of slides from NASA. It came out pretty recently. They had a workshop, so they have this, more general, they have this AAM, Advanced Air Mobility working groups. And one of them recently looked at vertiport location considerations. I will just flip through the slides. There is mostly text, so somewhat boring, or more boring than the slides from DLR. But again, this is kind of for you as a placeholder for where you could look for things and information related to considerations for vertiport location. So they had some kind of brainstorming. I didn't take part in it. I only see the slides, and yeah, they were just putting in ideas. They understood it was important to work with the regulator, FAA in their case. Yes, some of the notes, and finally the considerations. So there were really lots of different groups with whom you have to consult, and all of them had these different considerations. Yes, I don't know if we stop at this one. Okay, physical. Yeah, we know that buildings, antennas, and towers, and all these obstacles are important. So that somehow relates to other slides that we've seen. Yeah, some of these obstacles will be mobile and temporary, like the cranes, debris, and other things. Yes, land use and other things. Altogether, lots and lots of considerations, including economic considerations, environmental considerations, noise, and other things. Airspace, we are very well aware of it. There are other flying objects in the vicinity, including conventional aircraft. Demand, we want to put them in high demand areas, but probably not in noisy areas. Yes, contingency, how do you deal with that? Equity and other things, utility, safety, and all that. Automation is important, many other considerations. Again, just flipping through the slide, lots and lots of considerations. Probably if some of the groups would want an extra project in this course, I would, or I could give a project to list all the considerations for vertiport locations, and then we would see whether the students in this class do better than NASA workshop or worse. And then the question, of course, how do you measure what is better, what is worse? But in terms of the number of considerations, in terms of number of points, I think, well, NASA did a pretty good job. Lots and lots of considerations for vertiport location. Okay, so vertiports for air taxis, yes, will be an important piece of infrastructure. Maybe there will be less infrastructure for the smaller drones, or I would say hopefully, not just maybe, but hopefully, that would let them fly and take off faster. So the minimum infrastructure that you can think about for the smaller drones, maybe you would have a QR code for landing. Of course, if you have a camera on the drone, if you're allowed to use the camera, and so on and so forth, because there are all these privacy considerations. But I have seen very good work where they would land drones on moving trucks, where they would land them on a ship. And again, it would be hard to position the drone using just GPS or whatever. You really have to be precise down to centimeters. But when they introduced the QR codes, then the drones were able to land even on something unstable, like a moving truck or things like that. So QR codes, maybe, again, that's my view. Kind of navigational aids, I mean, they are also phasing out even in conventional aviations. You don't need the beacons and everything else with all the GPS and similar technologies. Well, maybe in urban environments where GPS is not so good, maybe you could do some extra beacons for positioning. I mean, radio type of beacons, not the QR codes. The question is, yeah, the cost-benefit analysis. Who's going to pay for it, and how much benefit they bring in terms of the precision of landing and so on. QR code is cheap, right? I mean, we can print, we can produce them. Probably we've done it ourselves and paint, or I don't know, glue. And yeah, if the camera is already on the drone, then it's only a question of software. But really, these extra beacons or something else, I don't know. But maybe others do. In my feeling, what would be more likely as the infrastructure for the drones is something that we already mentioned and NASA mentioned. The weather is an important player, and I feel that there is not enough weather sensors in urban environments, really, especially to measure this urban weather, the hyperlocal winds, or these heat spots and other things. I guess they are needed, but again, the question is who's going to pay for it and how much benefit they bring. That's important. But yeah, it's a bleeding edge topic. there is Cesar Innovation Days that will happen this week, tomorrow, Wednesday, and Friday. And on Wednesday, there will be this paper by our colleagues from NLR, from the Netherlands, where they will be doing the hyperlocal winds now custom specifically for U-Space. And they just posted the paper. I didn't have a chance to look at it, but judging from what I know, I've seen some of their presentations. They are actually flying drones to understand what the wind pattern is and to give it to the U-Space so that U-Space gives it to all the other drones. I'm looking forward to the presentation, but at this particular point, sorry, we are 2 days early. I cannot say anything more intelligent about it. Yeah, I think this is a wonderful idea to use drones themselves as sensors. It has been raised well, with some frequency in the conventional aviation also. You know, when an aircraft flies up there in the air, it's a sensor which costs $1 million. So they could have sensed more of the weather, in particular, things like turbulence. They could have reported it automatically instead of the pilots reporting to controllers and controllers then reporting to other pilots. Anyway, we hope for much higher level of automations in the drone arena, and we'll see. The drones will hopefully be used as the weather sensors. If you're interested, let's learn more from this paper, and the presentation will also be on the Cesar Innovation Days website. Okay, so coming back to the vertiport placement for passenger, for air taxis, people carrying taxis and things like that. Just as the last slide, again, it's most important to understand where you can and where you should place the vertiports. And well, these geometry considerations again go from the airspace availability slides, given the different slopes or different envelopes, how they would take off and land. There are different places where you can or cannot place the vertiports. Again, as we saw at other slides, in focus health integration into other modes of transport is very important. You probably would want to reach other modes of transportations with the drones, or vice versa. And then one thing that we mentioned only briefly, but which is actually a huge topic, is what will be the energy that they fly on. It could be hybrid, it could be electric. We're hoping that it will be more and more electric, eVTOL. And then the question is, how do you get enough energy where the power grid is strong enough? That's also a very important topic. Again, of course, power grid is not a unique infrastructure which is done specifically for UAM. We have the power everywhere in our houses, but how to deliver it, for how long to charge the aircraft before the takeoff. These are all very interesting questions, and I would like to watch this video from Brian Jorman. He is at Georgia Tech doing a lot of good work on optimization of this charging. Yeah, so looking at how the batteries charge, that they charge very fast in the beginning, but then if you really want to fill up to 100%, then it takes a lot of time. So maybe it's better to fly with, half full, half empty battery, and then charge more often. All these questions. This is a longer video, about 1 hour, but worth watching, and that's something I hope you can do on your own at some point.